So you can see the maximum scale here is 1.63 e to the minus 1. But that scale maxes out, and then you get the black and white on top of that. And the black and white areas are a lot stronger than the scale can indicate. I'd have to start the image generation in what was the highest point in order for that scale to get auto-generated correctly. But it looks to me like it's way above 1, and I can verify that once I generate the CSV files. This is the H field X component, and this is 51 frames per cycle. So we're looking at extremely small time scales here and a much finer time granularity than we have been able to before. These data files are 11 gigabytes each. There's 3 for the E field, X, Y, and Z, and 3 for the H field. What I'm trying to do is just with the H field. I don't really have, I'm not really showing the E field, so I should be able to generate a slightly better resolution of the geometry, and I can also generate 100 frames per cycle, which is kind of my goal. I just have that number in my head, doesn't really mean anything. In order to be able to look at the magnetic fields here in this frustum cone design. This is the seashells, Michelle's design physical layout. The control files from Arrow, all I've really done is changed when the output gets generated. I haven't changed any of the rest of the geometry, and as soon as I get what I'm looking for here, I'll archive all of this, make it available for the EM Drive DIY community. Emery Stegmer Vax Headroom. This is the 22nd of December 2015, about 9 o'clock in the morning Eastern Time. This run took 22,000 seconds to complete, so about 6 hours. And as I said, generated 6 data files. Look over here. 6 data files at not enough space to show that. 11 million kilobytes each, so 60 total of about 66 gigabytes. So the run I want to do is probably going to run about 12 hours or more, and probably generate about 100 gigabytes worth of data. Generate the common separated value files for that in order to pull them into Pavre is going to be fun.